This is a longer video that explains the different functionalities of the E-Man 2000 remote control tank. Alright, to start we have an LCD screen right here that will display constantly the degrees and angles. We have 7 buttons over here that does the different commands. Here is the XP, and it is attached, as you can see over here. It is shooting a blinking light green to show that it's doing a DN. So it's taking in the data, and then it sends it over here. As you can see, it's blinking red. That's the D out, so it receives. Next, we have the display here. It displays the degrees and angles. So whenever you increase the degrees, it increases by 10, and this increases by proportional to the degrees. It has a range of around 200, so you divide that by 180, and that's how much you increase by. Next, we are dealing with is the different parts over here. So we have two different mechanics for the turret system. We have the servo motor that controls the arc length this way, and we have a servo motor on the bottom for the base that turns it this way. Since servo motors can only move at 180 degrees, this gives us full range of motion from whatever around the whole entire tank. Next, we can flip this up so we can take a peek inside the other components. These are all 100% detachable. So we can flip this up and look at the other different types of components here. So here we have another Atmega, and here is the H-bridge described over here. Each one of the H-bridge has a pin to its base that's connected to port B of the Atmega. And these are connected to there. So only by activating two of the PNPs, transistors, we can turn the treadmill a certain direction, because it goes from power through the transistor gate, goes through the motor, goes through here, then through another transistor gate, it goes to ground. That we can do for both directions and for both motors. The way to change the direction of the motor is just to change where the input for ground and power is by switching them. Next is this light over here is for testing purposes only to test different pins and the data that comes in. Right now it has no other functionality. Next we have we can lift this up and we can see that there is two battery packs in parallel. So, connected to this and soldered to a 3-prong switch at the bottom. If it can be seen, there it is. With this turned off, pressing this button won't do anything, as shown. However, if we turn it back on, pressing this button turns it back on. It resets everything. As shown, there are some bugs, such as this starts always at the same place, even though it says degrees 10 and 120, it starts at the same place. Second bug is that this board, as you can see there is no light, is because it is faulty. So you have to get it in the correct position. Let's see if I can do it right here. One second. And put it in like so. Oh, I guess I can't right now. And the third bug, which is, well, it cannot turn. This is because both motors are applied over here, right here. So the pivot, when it's changing its direction, this one going forward and this one turning backward, which should turn it this way, have a pivot right here. However, the center of mass is right down here, which resists the change of the pivot. It's trying to pivot like so, instead of trying to pivot like so. That is why it cannot turn. And that is everything.